Imagine a robotic rotorcraft flying over the dunes of an alien moon. Sounds like science fiction, right? Well, it's about to become reality. Find out more in today's episode.
3, 2, 1. Engine full power.
Welcome to Your Space Journey, where we venture into the future of space exploration. Your journey begins now.
Hello and welcome to the 4th season of Your Space Journey. Thank you so much for joining me. I'm your host, Chuck, and today we're going to dive into a mission to Saturn. It's called the Dragonfly mission. It's actually going to be a space helicopter that's going to go explore the moon of Saturn's largest moon, Titan. Joining me today is the principal investigator of Dragonfly, Elizabeth Turtle. Dragonfly, an upcoming mission from the Applied Physics Laboratory, is a pioneering project that aims to explore Saturn's largest moon, Titan. The mission will send a rotorcraft called Dragonfly to Titan's surface to study its geology, atmosphere, and potential habitability. Titan is of particular interest to scientists because it has a thick atmosphere, stable liquids on its surface, and a complex chemistry that is similar to that of early Earth. Dragonfly will be able to fly to different locations on Titan, land and take off again, and conduct in-situ measurements with a suite of scientific instruments. The mission is set to launch in 2027 and will arrive at Titan in 2034. The mission is expected to provide new insights into the origins of life and the potential for life elsewhere in the solar system. Elizabeth Zibi Turtle, the principal investigator for Dragonfly, joins us today to discuss this incredible mission. Zibi was an associate of the imaging team on the Galileo mission and an associate of the imaging and radar teams on the Cassini mission. She also serves as co-investigator working with the camera on board the Lunar Reconnaissance Orbiter spacecraft.
Your Space Journey.
Zibi, thank you so much for joining me today.
My pleasure.
Well, I tell you, we love to talk about people's space journey, and you have a fascinating one. I kind of want to go back to the beginning because you've had an amazing career so far as planetary scientist. But I understand you sort of got some great influences by your dad, your grandmother, even a favorite board game. I was wondering if you could just tell us how your fascination with space came about.
Sure. Yeah. I've just always been interested in space. As you refer to, I've been it was kind of always a part of our lives because of my dad and my grandmother's fascinations with the sky as well. So we were always looking up. My dad would take us out to look for comets and meteor showers and things like that. And then, my sister and I had a board game called Space Hop that we played all the time, where you had little missions to different places, and as in the 70s and 80s, Voyagers moved out through the solar system. The questions that were in the game, we started to learn what questions were outdated, what answers were outdated, as we learn more about our solar system.
See, what a great way. I love how you had some encouraging people throughout your life, and mentors, they make such a huge difference. So again, any of our audience out there, just say those encouraging words to kids, to others, just encourage them along. You never know what it might lead to. They might be heading up a team that's exploring a moon of Saturn, which is awesome. So Zibi, I have to say, many folks like me, I was greatly inspired the first time I looked at Saturn through a telescope. And I could see the moon Titan, of course. But now, you're leading a team that will investigate it. Can you just give us kind of that high level, big picture view of what the Dragonfly mission is and its objectives?
One of the big questions has been how life developed. But it's hard to go back on Earth to study the prebiotic steps, the chemical steps that occurred before chemistry took that leap to biology here on Earth. And it can be difficult to study in the lab because of the setup required and the timescales required. So we look to other places in the solar system that can give us pieces to this puzzle. And Titan, in many ways, especially chemically, is very like the early Earth. Titan is the largest moon of Saturn, it has an atmosphere. It's the only satellite in the solar system that has a dense atmosphere. And in fact, the atmosphere is actually denser than our atmosphere here on Earth. The atmospheric surface pressure on Titan is 1.5 times that here on Earth. Wow. So the atmosphere does a lot of interesting things. It's mostly made of nitrogen, like our atmosphere. But the next major constituent is methane, and that methane breaks down at the top of the atmosphere, and the remnants, the pieces left behind, recombine and form very complex carbon-rich molecules. But Titan, being in the outer solar system, is an icy satellite, so its surface is made of water ice. Like many of the moons in the outer solar system, it hosts in its interior a liquid water ocean, so it's an ocean world. So in the past at Titan's surface, there's been the opportunity for the surface to melt. For example, when you have an impact event that melts the target rock, but the target rock on Titan is water ice, and so when that melts, you get a nice warm pool of water. And in the interior liquid ocean, ocean there's liquid water in the present day, although deep beneath the surface. So Titan has not only these opportunities for there to be liquid water in the system, but it has a lot of very carbon-rich material. And of course, there's energy in the form of sunlight that's driving this chemistry in Titan's atmosphere. So the molecules that are formed in the atmosphere and fall out onto the surface have had the opportunity to mix with liquid water. So effectively, Titan has been doing the kind of prebiotic chemistry experiments for us that we want to do, here on Earth. And the results of those experiments are sitting on Titan's surface today. And so that's what motivates Dragonfly. Dragonfly is a mission to go to Titan to pick up the results of the chemistry experiments that it's been doing for us.
It's a fascinating mission. And I have to say, Zibi, you've got the coolest job, I was going to say in the world, but this kind of in the universe, really. Can you tell us more about just your role and responsibilities as principal investigator for Dragonfly?
Right. So, so I'm the principal investigator for Dragonfly. That means that I am responsible for the mission and for achieving the science that we have set out as our science objectives. On a day-to-day basis, it means I sit in a lot of meetings. But the big picture is, you're absolutely right. This is, I am exceedingly fortunate to get to work on planetary missions. It's absolutely thrilling. And one of the things that is particularly that I find particularly fun about this role is being able to see all the different parts of the project and how they're all coming together, right? This is a very tightly coupled spacecraft. All spacecraft are very complicated and present constrained or sometimes over constrained problems. Dragonfly in particular is a very tightly coupled system, and so things that you wouldn't necessarily expect to affect different subsystems very much do. And so it's just been it's always fascinating and so exciting to see how everything develops together. And to be able to work with this incredible team that's developing the different parts of this that are all coming together now as we get ready for our mission preliminary design review next month.
Wow, that's going to be fascinating too. And some of our audience, I was thinking about this, where they might be familiar with Ingenuity, the Mars helicopter, but Dragonfly is a lot different than Ingenuity, as Mars is much different than Titan. So this will be the first time that a rotorcraft like Dragonfly has flown on a moon in our solar system. Can you tell us more about just Dragonfly's size and general capabilities?
Yeah, absolutely. So, right. So Titan, as I said, the atmosphere of Titan is denser than our atmosphere. The gravity is lower. Titan is a smaller body. So the gravity is lower. So it's actually physically easier to fly on Titan than it is to fly here on Earth. A person, could put wings on and kind of soar over the surface of Titan, which would be thrilling. So Titan, in that respect, does a lot of the work for us. Dragonfly is designed as an octocopter, a rotorcraft lander, so that we can fly from place to place on Titan instead of driving from place to place. We actually spend most of our time on the surface making scientific measurements and communicating with Earth. So we spend most of the time sitting on the ground, and then we use flight to be able to travel from place to place. But to kind of speak to some of the differences with with the exploration of Mars and the spectacular Ingenuity helicopter, just to give you a sense of the different environments, because Mars of course has a much thinner atmosphere.
Right.
The Dragonfly lander is about the size of the Perseverance rover.
Wow.
So rather than the smaller helicopter for flight on Mars, we are actually flying a very large vehicle from place to place. And as I said, that's because Titan's environment is so conducive to flight.
So I think that's amazing. And one thing, though, kind of a disadvantage or something definitely different about Titan's environment is its hazy atmosphere. So you're unable to use solar power. But I understand you're going to use that RTG power source. I was wondering if you could just generally explain how does that work?
Yeah. So the illumination at the surface of Titan is kind of like the full moon here, because we're much further out in the solar system, and as you say, there's haze in the atmosphere, which is actually those very carbon-rich molecules that are produced at the top of the atmosphere falling through the atmosphere, and they produce these haze layers. So that when you see Titan from with the at visible wavelengths, at human visible wavelengths, you see this gorgeous atmosphere, and the surface isn't apparent. So yes, so there's less illumination at the surface, and of course, Dragonfly, because we're flying from place to place, we need to keep the lander compact, and so very large solar arrays aren't a feasible means of powering the mission. So just like the Curiosity and Perseverance rovers, we use a multi-mission radioisotope thermoelectric generator, or MMRTG, which powers the lander. The other benefit of the MMRTG is there's a lot of it's a fairly inefficient process generating power that way. So there's a lot of what we typically call waste heat. There's extra heat produced in that process. However, for Titan, where the surface temperature is 94 Kelvin, which is like negative 290 Fahrenheit, the waste heat is not waste at all, and it's what we use to keep the interior of the lander warm. So the electronics and all of the hardware inside the lander can be kept at appropriate temperatures to function. So we get two benefits from the MMRTG.
That's so impressive. It's going to be fascinating. Now, if I understand your launch and landing timeline, launch I think is 2027 with arrival 2034. And I was is that true? And like how long will the Dragonfly mission is expected to last, I guess?
We're scheduled to launch in June of 2027, and that gets us to Titan by 2034.
Okay.
It's a long way to the outer solar system. The mission itself is a little over 3 years.
Wow.
So the plan is to explore Titan's equatorial, part of Titan's equatorial region. There are, just to give a sense of how familiar, how Earth-like Titan is, the equatorial region on Titan is actually covered in dunes, in sand dunes. But on Titan, the sand dunes the sand itself is made of organic. It has an organic composition. And so the plan is to explore the area of the sand dunes, to measure the compositions of the sand of the interdunes, the clean areas between the sand dunes where you have a water ice bedrock, and then to explore up into deposits associated with an impact crater, the Selk impact crater, which is 80 kilometers in diameter, and is one of those places on the surface where liquid water and complex carbon-rich material may have had an opportunity to mix for possibly extended periods of time. And so we want to measure the compositions of the materials in these different environments to understand what kind of chemistry has been possible on Titan and how far it's progressed.
Wow. And speaking of how far, I mean, one thing that I thought was really amazing about Dragonfly is we're talking a lot more than just the tiny hops that Ingenuity did, which is great. But my understanding is it can go tens of miles in under an hour. How far can it fly during Titan's, say, daytime hours?
Titan's days are 16 Earth days long. So it's about 2 weeks, right? So the plan is to fly every other Titan day. That gives us extra time to make measurements, at each landing site, et cetera. And it gives us, backup if for some reason we don't fly on a certain day. So the plan is to fly about once a month. And in that, those flights are probably about half an hour long. And we go several, as you say, several kilometers in a single flight. And over the timescale of the mission, depending on where we land in the landing inlets, we'll go several tens or maybe more than 100 kilometers from our original landing site into the deposits associated with the crater. One of the things, though, that we don't have, because Mars has this infrastructure, right? There are a lot of orbiting spacecraft that can serve as relays for data from the surface of Mars. And that, in the case of MRO with the HiRISE camera, are taking very high resolution images of the surface. But we, for Titan, we don't have that. The Cassini spacecraft that orbited Saturn sent back spectacular observations. We know the geography of Titan. We know its general geology, but we don't have that high resolution, that kind of meter scale imaging or sub-meter scale imaging of the surface that we're used to for Mars. So Dragonfly, because we can fly, we can actually scout out our future landing sites in advance. And that allows us to, assess from a hazard perspective, want to make sure the landing sites are safe. But it also allows us to assess from a scientific perspective the scientific interest of different potential landing sites. So that's one of the things that we'll be doing differently, is doing our own scouting. And we do direct Earth communication from the surface of Titan because we don't have an orbiting relay. So that everything is self-contained, including our communication system.
That is incredible. Zibi, can I ask you this? What excites you personally the most about this mission?
Well, having worked on the Cassini mission, having seen the images come back from the Huygens probe that descended down through Titan's atmosphere in 2005, I think the anniversary of that descent was last week, actually. Anyway, having gotten to know Titan so well through that mission, the excitement of going back, it's just thrilling to be looking forward to going back to this, this really fascinating moon. Another thing that really excites me about the mission is that although we're a chemistry mission and, designed to make very detailed measurements of the chemistry of the surface, we can put that into the context of the Titan environment. And we have other instruments that give us the capability to measure different aspects of that environment, monitoring the meteorology, listening for Titan earthquakes, and cameras that will give us the view of the surface to understand the geologic processes going on, and possibly even see some of that transport in real time if the breeze is blowing the sand across the surface, et cetera. So I like that we can kind of get the big picture and put the detailed chemistry into those observations that will give us the bigger picture of this area of Titan and how it fits into Titan as a system.
Zibi, I love your enthusiasm. I think it comes across good. And I think it's actually very motivational for a lot of our audience out there. And we do have sometimes parents, kids have listened to this program before. Just wondering, just as successful principal investigator, what advice would you give to kids out there who want to pursue a career in space exploration?
One can look at people's careers, at people's CVs or resumes, right, and connect dots and say, oh, here's a natural progression. But what you don't see in those resumes is all the proposals that weren't necessarily successful. And you still learn things from them, right? That's, taking the learning away from the things that don't work, from the proposals that aren't selected, et cetera. And I've certainly had those as well. Gives you the next the information for the next step, and kind of building off of experience, whether or not, it leads to a success to try the next thing. That kind of perseverance is important, and something I've tried to do is find what I can learn from each step. The other thing that I'd say is that while we look at planetary missions or spacecraft missions in general, and we think about the technology, we think about the engineering, we think about the science, the teams that work on these missions are multidisciplinary, right? It's not just scientists and engineers. There's an entire branch of the project that is the project management. Right, this is the people that actually make everything happen and make sure the resources are distributed, so the scientists and the engineers, can each do their pieces of the mission. But also the graphic designers, right, who do who take the CAD model and do renders, so you can see what Dragonfly will look like in the Titan environment, right? There's a lot of that side of Dragonfly as well, the augmented reality, the virtual reality that we will rely on as we're exploring Titan to kind of put ourselves into Dragonfly's place on Titan as we do the exploration. And of course, people doing computer programming as well, right, which Dragonfly, we didn't talk about it, but Dragonfly's flights, for example, have to be entirely autonomous. So, right, all of that computer programming is absolutely essential. And so while we think about, some of the technical roles more specifically for these missions, the team that is developing Dragonfly, which is hundreds of people, includes people with all sorts of different backgrounds. And so, even if you're not going into engineering, but you're interested in space, right, there are a lot of different avenues to participate, and all of these roles are absolutely crucial to the mission.
Oh, that's fantastic. Wonderful advice, and just wonderful big picture of how it takes so many people from so many different disciplines to come together. Zibi, I just want to thank you so much for taking time to join me. Wanted to wish you and your awesome team the best for Dragonfly. We're certainly going to keep a close eye on this mission. Thank you so much.
Thank you. It was a pleasure to talk with you.
Your space journey.
Well, I really enjoyed my conversation with Elizabeth today, and I'm so excited about the Dragonfly mission. I hope you are too. If you'd like to learn more, just go to their website. I put it in the description. It's also dragonfly.jhuapl.edu. I want to thank Zibi for joining me today. I want to thank you for joining me as well. Again, we'd appreciate it if you do a small favor and share this episode with a friend. Thanks so much for joining me. I'll see you next time. God bless.